What were the first radiation risks during the moon landing? Have you ever wondered what dangers astronauts faced during the historic moon landing? One of the most pressing concerns was radiation exposure. As the Apollo missions ventured beyond Earth, astronauts encountered various sources of radiation that posed health risks. The first major source was the Van Allen radiation belts. These are zones filled with charged particles trapped by Earth's magnetic field. When Apollo 11 traveled through these belts, astronauts experienced radiation levels of about 1.67 millisieverts per second. Over 3 hours, this added up to around 1.8 sieverts. To put that in perspective, exposure above 1 sievert can lead to severe health issues. Thankfully, the actual skin dose was lower than what might be expected, similar to what astronauts experience in low Earth orbit. Another risk came from solar particle events, which are bursts of energetic particles from the sun. These events can dramatically increase radiation levels. During the Apollo missions, no major solar flares occurred, but a flare between Apollo 16 and 17 could have been dangerous. If astronauts had been exposed without protection, they could have faced radiation sickness or worse. Galactic cosmic rays also contributed to the radiation exposure. These high-energy particles come from outside our solar system and can penetrate deeply into the body. They can damage DNA and increase the risk of diseases like cancer and cardiovascular issues. Research has shown that Apollo astronauts have higher rates of cardiovascular disease compared to those who only flew in low Earth orbit, likely due to this radiation exposure. To protect astronauts, the Apollo spacecraft had some shielding. The spacecraft was made with aluminum alloy that was about 7 millimeters thick. While this offered some protection, it was not enough against all radiation types, like gamma rays or neutrons. The spacesuits were designed with materials like aluminum, titanium, and Teflon, but they did not include lead, which is typically used for radiation shielding. This was due to lead's weight and impracticality for spacesuits. The Apollo missions highlighted the challenges of human spaceflight beyond Earth's protective atmosphere. While short-term exposure to space radiation was survivable, the long-term health risks remained a concern. For future lunar missions, research suggests that habitats covered with at least 50 centimeters of lunar soil could provide better protection against radiation. Additionally, deeper shelters with around 10 meters of water shielding would be necessary for intense solar storms. Today, early warning systems using satellites help astronauts prepare for solar events, giving them time to seek shelter. The Apollo missions not only achieved remarkable milestones but also laid the groundwork for understanding the risks of space travel.